Good afternoon, friends. Today I am going to the design of riveted joints. Last class explain the introduction to the riveted joints and types of riveted joints, materials of the riveted joints, and failures of riveted joints. Today I can explain the efficiency of a riveted joint. Efficiency of a riveted joint. The efficiency of a riveted joint is defined as the ratio of strength of riveted joint to the strength of unriveted or solid plate. Okay, we have already discussed that strength of the riveted joint equal to least of PT, PS and PC. Strength of the unriveted or solid plate for pitch length P equal to P into T into sigma T. Okay. The efficiency of the riveted joint equal to least of PT, PS and PC divided by P and T and sigma T. P equal to pitch of the rivets, T equal to thickness of the plate and sigma T equal to permissible tensile stress of the plate material. These are the efficiency of the riveted joint. Next problem. Find the efficiency of the following riveted joints. Okay, na? A single riveted lap joint 6 mm plates with 20 mm diameter rivets having a pitch of 50 mm. Next, double riveted lap joint of 6 mm plates with 20 mm diameter rivets having a pitch of 65 mm. Assume the permissible tensile stress in a plate is 120 megapascal. The permissible shearing stress in rivets that equal to 90 megapascal. The permissible crushing stress in rivets that equal to 180 megapascal. This is the problem. We can solve the problem by using of a data book geology. Okay, first of all, to write down the given data, T equal to 6 mm. Okay, thickness of the plate. Next, D equal to 20 mm, diameter of the rivet hole. Next, sigma T equal to permissible tensile stress. Okay, 120 megapascal. That equal to the unit conversion 120 Newton per mm square. Okay, now stove shearing stress tau equal to 90 megapascal. That's converted into Newton per mm square 90. Okay, now sigma C and crushing stress that equal to 180 Newton per mm square. These are given data. First, the efficiency of the first joint. The efficiency of the first joint. Okay, na the pitch P equal to 50 mm is given. Okay, na first of all, let us find the steering resistance of the plate, shearing and crushing resistance of the rivets. Okay, na first steering resistance of the plate. We know that steering resistance of the plate per pitch length. Okay, na data book page number 10.6. Okay, na data book we can follow the data book page number 10.6 page. Okay, pt equal to p minus d into t into sigma t. This formula is taken from the data book page number 10.6. Okay, that equal to 50 minus 20, okay, into 6 into 1, that is 21,600 newtons. Okay, now the shearing resistance of the rivet, okay, since the joint in a single riveted lap joint, therefore the strength of the one rivet in a single shear is taken. We know that shearing resistance of one rivet that equal to 5 by 4 into d square into tau. Okay, now 5 by 4 into 20 square into 90, that equal to 29,278 newtons. Okay, now shearing resistance. Next, crushing resistance of the plate. The crushing resistance of the plate is taken from the data book. Tc equal to d into t into sigma c. Okay, now that is calculated. Value is 21,600 newtons. The strength of the joint list of PT, PS and PC equal to 21,600 newtons. Okay, we know that the strength of the unriveted solid plate P equal to P into T into sigma 2, that equal to 36,000. The efficiency of the plate, the efficiency of the joint, the efficiency equal to list of PT, PS and PC divided by P, that equal to 0.60, that equal to 60%. Okay, now the efficiency of the second giant, the pitch P equal to 65 mm already given in the problem. Okay, same procedure. First of all, we calculate the steering resistance, next shearing, next crushing. Okay, na first steering resistance, PT equal to P minus D into T into sigma T, that equal to 32,400 meters. Next, shearing resistance of the rivets, PS equal to N into pi by 4 into D square into tau, that equal to 56,556 newtons. Okay, next to crushing resistance. Crushing resistance PC equal to N into D into T into sigma C, that equal to 43,200 newtons. Okay, now next strength of the joint east of PT PS PC equal to 32,400 newtons. So next we know that the strength of the unriveted or solid plate equal to P into T into sigma T, that equal to 46,800 newtons. Okay, now the efficiency of the second plate. Okay, list of PT PS PC divided by P equal to 69.2 percentage. Okay, na next problem. We can solve the next problem. Okay, na that problem is to calculate the efficiency of the first plate and efficiency of the second plate. This problem is over. Okay, next, a double riveted lap joint is made between 15 mm thick plate, the rivet diameter and pitch 25 mm and 75 mm respectively. If the ultimate stress 400 megapascal in tension and 320 megapascal in shear and 640 megapascal in crushing, find the minimum force per pitch which will rupture the joint. Okay, na? First given data, we can write down the first given data T equal to 15 mm, D equal to 25 mm, P equal to 75 mm, sigma Tu equal to 400 megapascal. Next, tau u equal to 320 megapascal. Next, sigma Ce equal to 640 Newton per mm square. Next, minimum force per pitch, which will rupture the joint. Minimum force PTU equal to P minus D into T into sigma TU equal to 3 lakhs newtons. Okay, na? The minimum force per pitch with the rupture the joint. Okay, we can calculate the value. Next, the ultimate shearing resistance. The ultimate shearing resistance of the rivet per pitch P SU N into pi by 4 into D square into tau u. Okay, na? That equal to 3 lakhs 14,200 newtons. N equal to 2 and 2 rivets hole. Next, the ultimate crushing resistance of the rivet per pitch. Okay, PCU equal to N into D into T into sigma Q, that equal to 4 lakhs 80,000. Okay, newtons. Okay, next, actual thrust produced in the plates of the rivets equal to 75,000. Okay, na sigma TA, tau A, and sigma CA be the actual tearing and shearing and crushing stresses are produced in a safe load. Okay, 75,000 tearing and shearing and crushing. Next, we know that the actual tearing resistance of the plates 75,000 equal to P minus D into T into sigma TA. That equal to sigma TA equal to, you can calculate the value 100 megapascals. Okay, these problems are taken from the RS Kurmi textbook. Okay, na actual shearing resistance of the rivets, shearing resistance of the rivets, PSA equal to 75,000 calculated value. Next to that equal to n into pi by 4 into d square into tau A. Next to tau A is calculated 76.4 megapascal. Next, actual crushing resistance or calculated value is sigma CA equal to 100 megapascal. Okay, na last problem is closed. Next, design of a boiler joints. Design of a boiler joints is most important topic in this chapter. Mostly asked previous questions in this chapter. Okay, na? The boiler has a longitudinal joint as well as a circumferential joint. The longitudinal joint is used to join the ends of the plates to get the required diameter of a boiler. For this purpose, a butt joint with two cover plates is used. The circumferential joint is used to get the required length of the boiler. For this purpose, a lap joint with one ring overlapping the another alternatively is used. Since a boiler is made up of number of rings, therefore the longitudinal joints are staged for convenience of connecting rings at places where both longitudinal and circumferential joints occurs. Okay, assumptions in designing of a boiler joints. Assumptions in designing boiler joints is most important question. Assumptions in designing boiler joints. Okay, now the first one, the load on the joint is equally shared by all the rivets. The assumption implies that the shell and plates are rigid and that all the deformation of the joints takes place in the rivets themselves. Rivets themselves. Okay. Next, second one, the tensile truss is equally distributed over the equally distributed over equally distributed over the section of metal between the rivets. Section of metal between the rivets. The shearing stress in all the rivets is uniform. The crushing stress is uniform. Okay, next, there is no bending truss in the rivets. Okay, now next, sixth one, the holes into which the rivets are driven do not weaken the member. Next, the rivet fills the hole after it is driven. Next, the friction between the surfaces of the plates is neglected. Okay, na? These are the assumptions of the boilers. Okay, next, design of a longitudinal butt joint, but a boiler. First one, thickness of the boiler shell. First of all, the thickness of the boiler shell is determined by the using the thin cylindrical formula. Okay, T equal to PD by 2 into sigma T into efficiency plus 1 mm. The correction allowances. Okay, plus 1 mm is the correction allowances. Where T is the thickness of the boiler shell, P is the steam pressure in the boiler, D is the internal diameter of the boiler shell, sigma T is the permissible tensile stress. Efficiency of the longitudinal joint. Efficiency L అనేది efficiency of the longitudinal joint. Okay, na? Next, the following points are maybe noted. Okay, first, the thickness of the boiler shell should not less than 7 mm. The thickness of the should not less than 7 mm. Okay, second one, the diameter of the rivets after finding out of the thickness of the boiler shell T, The diameter of the rivet hole D may be determined by using uneven empirical formula. Okay, D equal to 6 into sigma T, where T is greater than 8 mm. Okay, next, the longitudinal butt joint for a boiler. Third point, the pitch of rivets. The pitch of rivet is obtained by equating the tearing resistance of the plate to the shearing resistance of the rivets. It may be noted that first one, the pitch of the rivets should not be less than 2D, okay, which is necessary for the formation of head. The maximum value of the pitch rivets for a longitudinal joint of a boiler as per IBR, okay, Indian Standard Boiler. Okay, P maximum equal to C into T into plus 41.28 mm. Next, C equal to thickness of the shell plate in mm, and C equal to constant. Okay, now next, fourth one, distance between the rows of rivets. The distance between the rows of rivets as specified by the Indian boiler regulations. Okay, na? Specified by the Indian boiler regulations. These formulas are all available in the data book. Okay, next, for equal number of rivets in more than one row per lap joint or butt joint, the distance between the rows of the rivets, okay, PB, should not be less than, okay, na, 0.33p plus 0.67d per riveting and 2d per chain riveting. Okay, na, 0.33p plus 0.67d per jig riveting, 2d per chain riveting. Next, for rivets, for joints in which the number of rivets in outer rows is half the number of rivets in inner rows, and if the inner rows are chain riveted, the distance between the outer rows and the next rows should not be less than, okay, 0.33p plus 0.67, okay, or 2d, wherever is greater than. Okay, now next, the distance between the rows which there are full number of rivets shall not be less than 2d. Okay, now next, third point, for joints in which the number of rivets in outer rows is half the number of rivets in inner rows, and if the inner rows are zigzag riveted, the distance between the outer rows and the next rows shall not be less than 0.2p plus 1.15d. The distance between the rows in which there are full number of rivets zigzag shall not be less than 0.165p plus 0.67d. Next, fifth one, thickness of the butt strap according to the Indian boil regulation. Okay, first one, the thickness of the butt strap in no cases shall be less than 10 mm. T1 equal to 1.125 T for ordinary single butt strap. T1 equal to 1.125 T into P minus D by P minus 2D. This is the single butt strap. Next, 0.625 T is the double butt strap. Next, 0.625 T into P minus D by P minus 2D for the double butt strap. Next, for unequal with the butt straps, with the thickness of the butt straps are T1 equal to 0.75 T, T2 equal to 0.625 T. Okay, na? Next, margin. The margin is taken as 1.5 D. Okay, na? Next, the problem. Okay, design the longitudinal joint for a 1.25 diameter steam boiler to carry a steam pressure 2.5 Newton per mm square. The ultimate tensile strength boiler plate may be assumed as 420 megapascal. The crushing strength 650 megapascal, and the shearing strength as 300 megapascal. Take the joint efficiency 80%. Adapt the suitable factor of safety. Okay. First of all, to write down the given data, D equal to P equal to sigma TU, next sigma CU, next tau U, next to efficiency. Next sigma T equal to sigma TU by factor of safety. Factor of safety is taken from the 5. Okay, now next to sigma C, next to tau U by tau J trust. Okay, now next to the thickness of the plate. T equal to PD by 2 into sigma T into efficiency L plus 1. Okay, now that equal to 25 mm. Okay, next diameter of the rivet. Thickness of the plate is more than 8 mm. Therefore, the diameter of the rivet hole is D equal to 6 root T. 6 root 25, that equal to 30 mm. The data book page number 10.19 page, all equations are available. Okay, data book 10.19 page number. Okay, now next, the pitch of the rivets according to the Indian boiler regulations, P maximum equal to C into T into plus 41.28. Okay, this is the data book 10.24 page number. Okay, C value is a constant. This is taken from the data book 10.4 page number, that equal to 6. All values are substituted in the P maximum equation, so that equal to 220 mm. Okay, next P dash equal to pitch of the rivets in the inner row equal to 220 by 2 equal to 110. Okay, na? Next, the distance of the rivets. Then the distance between the rows of the rivets, that equal to 0.2 P plus 1.15 D, that equal to 87.2 83.7. Okay, that equal to 85 mm. Next, the distance between the inner rows for jig riveting 0.165 P plus 0.67 D, that equal to 60. Okay, now next point, thickness of the butt stab T1. T1 equal to 0.75 T equal to 0.75 into 20 equal to 21. Okay, the T1 value and inner rows jig riveting next in the outer row and the next row, these values are taken from the data book page number 10.2 something, అంటే 10.9 or 10.11 or something. Okay, now next, margin M equal to 1.5 D. Okay, D value 34.25. That value is calculated value 52 mm. Okay, let us now check the efficiency of the designed joint. Okay, tearing resistance of the plate in the outer row, PT equal to P minus 3 into T into sigma T, that equal to 3,89,550 newtons. Next, shearing resistance PS equal to 4 lakh 46 4 lakhs 76 820 newtons. Next, crushing resistance 6 lakh 3,750. Okay, na. Next, combined tearing and shearing resistance P minus 2D into T sigma T plus 5/4 into D square into tau. That calculated value 3,73,196 newtons. Okay, now from above we see that the strength of the joint 3,73,196. Okay, 196. The strength of the unriveted or solid plate P equal to P into T into sigma T, that equal to 4,62,000. Okay, the efficiency of the design joint equal to 80%. Okay, now okay, the problem is completed in this today in this class is stopped.